Hello, so we are going to solve the self-assessment, and in this case is number 1. Remember that right now we are doing solving nonlinear systems of equations that we're using 3 different methods. So method number 1 is graphing, and we have substitution and elimination. So problem number 9, as we can see, this equation, the second, I'm going to mark this one. Remember, equation number 1, and this one is equation number 2. And equation number 2 is already solved for one of the variables. So the most obvious option in this case is apply substitution. So I will take all this expression and employ it in the y square in equation number 1. For example, I'm going to have x squared plus, open parenthesis, 1/2 x plus 1/2 to the second power equals to 1. Now what I'm going to do is expand this binomial. And remember that we have the special formula a plus b to the second power, which is a squared plus 2ab plus b squared. We're going to apply it to this binomial. So for example, if I have 1/2 x plus 1/2 to the second power, remember I'm going to take this first term as a and this fraction as b, and this is equals to 1/2 x to the second power plus 2 times 1/2 x, which is a, times 1/2 plus 1/2 to the second power. If we simplify, 1/2 to the second power is 1/4 x squared plus 2 times 1/2 is 1. So I have 1/2 x, because 1/2 x plus 1/4. So what I have here is x squared plus 1/4 x squared plus 1/2 x plus 1/4 equals to 1. Now I'm going to simplify. These two are like terms. Also, I'm going to move one to the left, and then we simplify. So what I have 1 plus 1/4. And remember, I like to do same or like denominator. So I need a denominator 4. But if I put the denominator, I need to multiply the numerator by the same number. So what I have is 4/4 plus 1/4 equals to 4 plus 1, 5/4. So I have 5/4 x squared plus 1/2 x, and then I have 1/4 minus 1, and this one is going to be negative 3/4 equals to 0. Okay, so I have my expression. Now what I'm going to do is multiply. See that I have 4, 2, and 4 in the denominator. I'm going to use 4 because it's my common, and then I have 2, and multiply every single term and both sides of the equation by 4. So I'm going to multiply everything by 4. So 4 times 5/4, the 4 cancels out. So I have 5x squared. Now here, 4 times 1/2 is 4/2. 4 divided by 2 is 2 plus 2x minus 4 times 3/4 is 3 equals to 0. Now what I have is a quadratic equation. So we just factorize. We're going to try to factorize, and we can. And some of the videos that I have presented got how to factorize a quadratic equation using the Xbox method, or you can have quadratic formula. But this one will factor as 5x minus 3 and x plus 1, and this one is equals to 0. Now remember, I'm going to apply zero product property. So I have 5x minus 3 equals to 0, or x plus 1 equals to 0. Solve for x. x is equals to 3 over 5, or x is equals to negative 1. Because this is a nonlinear system, I'm going to have two sets of solutions. So far what I have is the value of x. So it's indicating so far that I'm going to have two sets of solutions. So now I take equation number 2. I'm going to write it here. Y equals to 1/2 x plus 1/2. And I'm going to evaluate these two values on this equation. So I'm going to start with 3 over 5. So I have y equals to, I'm going to write here, x equals 3 over 5. Then I'm going to have y equals to 1/2 times 3 over 5 plus 1/2. This is equals to 3 over 10 plus 1/2. If I have the same denominator, I'm going to multiply by 5. So it's 5 times 2, 10. So it's 5 over 10. So 3 plus 5 is 8 over 10. And if I simplify, I have 4 over 5. So y is equals to 4 over 5. So my first solution is going to be x is 3 over 5, comma 4 over 5. That's my first solution. Now I'm going for the second one. So I'm going to have here, if x is equals to negative 1, then I have y is equals to 1/2 times negative 1, and then plus 1/2. 1/2 times negative 1 is negative 1/2, plus 1/2, and this one is 0. So y equals to 0. So my second solution is negative 1, comma 0. You can prove it by graphing on Desmos or any graphing calculator, and this is going to be my solution of the system of equations.